Okay, so here's another example of debugging. Now this is a more elaborate example of something that you would have, because what if you have a longer code like this? Now here's the problem. You try to debug it the way you want to, but note that we're in release mode. And you see no breakpoints happened. And the thing is, why is that? Like, how come it didn't debug? But if you look at something like this, it will be like not a shaded in circle, and it's an exclamation mark, which means that's not going to break. So it's only going to run only certain things, and you will notice if you add it and it does that. Does that mean Visual Studio is not reliable? No, that's not the case. There's a temporary fix for this, but we're more encouraged to try debugging more, and not something like lazy debugging, which I can show later what lazy debugging is. So how do you fix something like this? Well, the simple thing is change this to be debug. And once from there, when we add something like this one, you get you finally get what you're supposed to be looking for. Which from there you can go through each one about what's happening to each of them. Now, something I didn't find until later is, do we have to add all these breakpoints to figure out what's happening between all of these? Well, the answer is no. You don't need to do any of this continue like that. That's why you don't need to have all of these breakpoints. And that might be overkill too. So for example, let's say you have this. You say, I want to see what first number is, but I do not want to see the result of division. So what you do is you can put continue. Like, remember that first number, second number, and division were specified? Right now it just has this very large number, which is negative 9.2559631331931178331 E61. And first underscore number is negative 9.25596313493178331 E61. And number 1 is negative 858993460. Number 2 is negative 858993460. Its second underscore number is negative 9.25596313493178331 E61. They're all these numbers because they're randomly generated, if I'm not mistaken. But if you put continue, you notice that division finally has this result. The reason is because we just skipped it. Now let's start using the other debugging tools, which is step into. So for example, we just do this, you step over, and you step into. So now you're in the division function. Then we step over, you start noticing that these will update the values, which result has this weird something, which is 8.0947714 8.09477154146 E negative 319 hashtag den. Which I'm not sure what this means, but that's just what it says. We finally initialize it, so now it says 0.0000000000000000000, and I think I said all of them, hopefully. And then we finally have number 1 divided by number 2, which were passed into our parameters, which is 1 and 2 basically, and we get 0.5. And then return it, and we exit the function once we put step over again. We finally move over here. So that's one way to step into a function. Another way to do this is if you do something like this. You put a breakpoint inside the function, so you don't need to do step into. You step over, then step over again, you notice it jumps here. And you do this, then we finally move over. Because whereas if you didn't do that, let's restart it, you didn't actually go into the function. Because putting step over right here will actually step over the entire function. So here's another thing you can do. So let's rerun it. When you step into division, what if you want to step out at some point? Like, oh, I get it. So step out, and that's how you leave the function entirely and do step over. Now, does it work when you have a breakpoint like this? And more, I would say yes, but let's try it right here. So step over, then step into, step over, step out. And unfortunately, it does not work because you have a breakpoint here. So you gotta make sure your breakpoints aren't there in order to step out. Then you can finally step over to the next line of code in main. And that's just the benefit of having these breakpoints and stepping into and stepping out. So let's finally debug what's happening in this complex program. Note that we don't need all these breakpoints. All you need is just a simple, you just need to know just the tools on the top, and then you should be good to go. And remember to have debug and not release mode. Okay, release mode is the reason why the debugging wasn't fully working. So you didn't need all the same as like I had in the previous one. So let's go ahead and debug this. So first underscore number, second underscore number in division are all initialized. Well, they will be initialized, but right now they have all these very large numbers. Well, it's very small numbers actually. Then they get initialized to these numbers. And we have division. And let's figure out what's happening for division. So we pass in first underscore number and second underscore number to division. So we're passing in the values 1 and 2. So we step into. So number 1 and number 2, they have different results here. Which this means not a number. That's what nan is. So it's actually a negative, not a number. And once we step over number 1 and number 2, which were parameters, they will now be initialized. Now result is it has this uninitialized value. So once we step over, it will be initialized to 0. We finally have number 1 divided by number 2. We assign that back to result. It gets updated 0.5. Then we return result. And then this actually, we could step out or do step over since we already have a breakpoint of right here. But I can show that soon. So we step over. We don't actually need this breakpoint, but it is recommend have the breakpoints on these, but we can just try without them for right now. So we have number 1 and number 2 that are barely going to be declared, but they're undefined, or actually they're uninitialized. What's happening here is we're static casting first an underscore number, which was 1, but it's going to turn into an int. Number 2 is going to be static casting second underscore number, which was 2. It'll become an int. So once we done that and initialize number 1 and number 2, you notice it's just 1 and 2 now in the bottom. So let's step into modify numbers, see what's happening. So in modify numbers, we have this passed by reference this time to number 1, to num1 and num2. Pay attention to this. So at the moment, we have unable to read memory. So you may have different kinds of uninitialized values. So initialize to 1 and 2. Temp num1 is 0. Temp num2 is 32,758. So we add 5 to both num1 and num2. But first num1 is going to be added. It's going to be having 5 added to it. So it changes to 6. And for num2, we add 5 to it, change to 7. Temp num1 and temp num2 are barely going to be declared and initialized. So we change these uninitialized values, which temp num1 is going to be assigned to num1, which is, oops. Yeah, let's start that over. Okay, so back to modify numbers. So I changed to 7 for num2. So we have these uninitialized values, which temp num1 will be 6. That's what num1 is. And temp num2 will be initialized to num2, which was 7. So these both got updated. It was done in a single line. And now we have the cout statement. The current values of temp num1 and temp num2 are temp num1 and temp num2, period. Then end of line. In our terminal, we have nothing in here. So once we step over, temp num1, remember it was 6, temp num2 was 7. So once we step over, you now should have the current values of temp num1 and temp num2 are 6 and 7. So let's step out because we do not have a breakpoint. And now we're in print result. So we actually just immediately stopped with no breakpoint. So if we go to print result, we can try this next one without the step out to show what happens without a breakpoint. So let's step into print result. So in print result, we passed in the following numbers, which is division, and note here, we passed in number 1 and number 2. In modified numbers, we have number 1 and number 2 that are passed into this function. However, it was a pass by reference. So because of pass by reference, whatever we change it for the parameters also affect back in main, which I didn't show you that, which sorry about that. But we will see a print result of what these numbers were. So we passed in division, number 1, and number 2. So we have R1, N1, and N2. These are the parameters, which was division, number 1, and number 2 respectively. They're uninitialized, so once we step over, we have initialized. And notice here there's 6 and 7 like the previous function, modify numbers. That's because when we passed them, we had passed by reference, passed into modify numbers, they affected these numbers too, number 1 and number 2, which we passed into print result. So N1 and 2 have the same thing, 6 and 7, as a result of pass by reference. And we just pass those affected values from main to print result. So we're going to have those two are new parameters, N1 and N2, if that makes sense. So we have the cout statement. The result of the divide number is R1 and del. Then make a new line, \n. Whereas the modified two numbers are n1 and n2, and then end of line. So let's step over, and we have this next one. So the divided numbers is 0.5, which was R1, the result, which was division. Division was this first one we passed into. The order, remember the order matters when you're passing to a function. So we passed in like number 1, then division, it'll say 6, which is wrong. That was not division. But that's because the way you passed them into. So it matters of which one you're passing for in the function call. It affects what numbers you have in this function. So the order really matters for what you pass into the function with the function call. And then that's what these parameters will be storing, if that makes sense. So we haven't displayed the second cout statement yet, but once we do that, we have this extra endel because of \n again, or more like the \n after the endel. And then where's the modified numbers? The modified two numbers are 6 and 7. So after we put step over, you just jump. It's kind of the same thing as stepping out, really. Stepping out if you want to end it sooner, but it's more beneficial if you have no breakpoints in this function, in the functions or somewhere else. If you're not like doing it with function but doing it with something else, then it also applies if you step out. So if we turn 0, then we could just end it right there. So that's a more advanced example of debugging.